As the sun enters a period of heightened activity known as the solar maximum, NASA seizes an unprecedented opportunity to study the effects of solar storms on Mars. This phase is critical for understanding how future astronauts and technology might fare on the red planet, which, unlike Earth, lacks a protective magnetic field to shield it from solar radiation. This video explores the potent forces of solar storms, NASA's strategic research initiatives, and the broader implications for Mars colonization efforts. Solar storms represent some of the most dramatic expressions of the sun's power. Occurring roughly every 11 years, the solar maximum is a period during which the sun exhibits increased magnetic activity, visible through numerous sunspots and solar flares. These solar flares, along with coronal mass ejections, CMEs, unleash torrents of electromagnetic radiation and charged particles into space. Solar storms involve a complex interplay of magnetic fields and solar plasma. A solar flare occurs when magnetic energy that is built up in the solar atmosphere is suddenly released. This energy heats the solar plasma to tens of millions of degrees Celsius, accelerating electrons, protons, and heavier ions to near-light speed. These particles radiate across the electromagnetic spectrum, creating not only visible light, but also radio waves and X-rays. Coronal mass ejections are even more impactful. These are enormous bubbles of radiation and particles from the sun's corona that are thrown into outer space, sometimes directly toward Earth or Mars. The speed and power of these ejections can create a geomagnetic storm capable of affecting electronic systems in satellites and on Earth. Mars presents a unique challenge when it comes to solar storms due to its thin atmosphere and lack of a global magnetic field. Unlike Earth, where the magnetic field and atmosphere provide effective shielding against these particles, Mars offers no such protection. This vulnerability can lead to significant atmospheric erosion, as charged particles from the sun strip away atmospheric molecules. The effects on Mars go beyond atmospheric loss. Radiation from solar storms can penetrate deep into the Martian surface, potentially threatening any life forms that might exist and posing serious risks to human explorers. The high-energy particles can break down chemical bonds, possibly changing the composition of the surface material. Understanding how solar storms affect Mars is crucial for several reasons. For robotic missions, solar radiation can interfere with electronics and data transmission, and even damage the physical components of spacecraft and rovers. For manned missions, the stakes are even higher. Solar storm activity could pose severe risks to astronauts' health, including increased cancer risks and acute radiation sickness. Therefore, NASA and other space agencies dedicate considerable resources to studying these storms. As we prepare for eventual human exploration of Mars, NASA's focus sharpens on understanding the Martian environment, particularly how it interacts with the solar wind during periods of intense solar activity. The tools at the forefront of this research are the MAVEN orbiter and the Curiosity rover, each playing a critical role in our understanding of Mars's radiation environment. Launched in November 2013, MAVEN's primary mission is to study the Martian atmosphere's upper layers, investigating how it interacts with solar wind and solar radiation. By orbiting Mars, MAVEN can measure the composition, structure, and escape of atmospheric gases. This is crucial for understanding how Mars's atmosphere has changed over time. During solar storms, MAVEN's instruments measure the increased influx of energetic particles and observe their effects on the atmospheric gases. This data helps scientists gauge how quickly Mars is losing its atmosphere, providing insights into the planet's climatic and atmospheric evolution. Moreover, MAVEN's ability to provide a warning system for increased solar activity helps safeguard other missions, both robotic and, potentially, human. While MAVEN observes from above, the Curiosity rover provides a surface perspective. Curiosity, which landed on Mars in August 2012, is equipped with the Radiation Assessment Detector, RAD. This instrument measures the radiation environment directly on the Martian surface. RAD's role is critical because it assesses the potential radiation exposure that astronauts would face on Mars. It measures both galactic cosmic rays and solar energetic particles, providing a clear picture of the fluctuating radiation environment that characterizes the Martian surface. By correlating RAD and MAVEN, researchers can form a comprehensive understanding of how solar events affect radiation levels on Mars, from the upper atmosphere to the surface. This is essential for developing effective strategies to protect future explorers. This also offers a robust model of Martian space weather conditions. This model aids in the design of spacecraft, habitats, and suits that can withstand the harsh Martian environment. For instance, understanding the intensity and frequency of radiation spikes allows engineers to develop materials that better shield astronauts from radiation. Moreover, NASA's preparation extends beyond just monitoring and measurement. They are actively developing predictive models that can forecast solar storm events and their impact on Mars. Such forecasting abilities are crucial for mission planning, especially for extravehicular activities, EVA, when astronauts are most vulnerable to radiation. The ongoing research also supports broader colonization efforts. By understanding the Martian environment's nuances, agencies can better plan for long-term sustainability on Mars, including how to utilize local resources, such as water ice, which could be affected by solar activity. The lessons learned from studying Mars's response to solar storms could also inform the development of technologies to possibly terraform the planet, making it more habitable for human life. Elon Musk's vision for Mars colonization is one of the most audacious goals in the annals of human exploration. By aiming to establish a human colony on Mars by 2050, Musk not only sets a timeline, but also pushes the envelope on what is scientifically and logistically possible. This vision requires overcoming monumental challenges, not least of which is the hostile Martian environment, exacerbated by solar storms. Initially, Musk proposed terraforming Mars by detonating nuclear explosives at its poles to release vast amounts of CO2, aiming to thicken the atmosphere and increase the planet's temperature to more Earth-like conditions. However, this method has been met with skepticism due to its drastic nature and unpredictable consequences. Given the challenges, the focus has shifted toward more viable and controlled methods of making Mars habitable. This includes constructing enclosed habitats that can shield inhabitants from radiation, developing life support systems that recycle water and air, and utilizing Martian soil for agriculture. Each proposal for making Mars habitable comes with its set of challenges and benefits. For instance, using Martian lava tubes as shelters could naturally protect against radiation, but would limit the space available for living and agricultural activities. On the other hand, building large-scale habitats with advanced materials might offer more space and comfort, but would require significant advances in material science and construction techniques. The impact of solar storms is a critical factor in evaluating these proposals. Intense and frequent solar storms could disrupt electronic systems, degrade habitat materials, and increase health risks due to radiation exposure. Each method's viability depends not only on its ability to provide shelter and support life, but also on its resilience to the effects of solar storms. To mitigate these effects, several strategies are being considered. These include enhanced shielding for habitats, the development of fast and reliable warning systems for solar storms, and potentially engineering genetically modified organisms that are more resistant to radiation for food production. As we look toward the future, the lessons learned from dealing with solar storms on Mars could have broader implications, even for Earth-based technologies. The resilience and innovations developed for Mars could help improve our ability to deal with solar weather and its effects here on Earth. In conclusion, understanding and preparing for solar storms is pivotal for Mars colonization. The strategies developed in response to these challenges will not only pave the way for Elon Musk's vision, but also enhance our overall capability to live and work in outer space. The road to Mars is paved with challenges, but each step we take is a leap toward realizing humanity's multi-planetary aspirations. Thank you for watching this video. If you found this information enlightening and want to dive deeper into the future of space exploration, don't forget to like, subscribe, and click the notification bell for more updates. Share your thoughts and questions in the comments below. Let's keep the conversation going.